Welcome back to the workshop. We want to continue taking a look at section 12.1, confidence intervals for one population proportion. So let's take a look at our notes. So we're looking at an example from the textbook. This comes from the exercises of our text. So during 1 year, Malaysia was the site of an encephalitis outbreak caused by the Nipah virus. Okay, so an infection. Cool. Skip down to here. Neurologists from the University of Malaysia found that among 94 patients infected with the Nipah virus, 30 died from encephalitis. So we want to find and interpret a 90% confidence interval for the percentage of Malaysians infected with the Nipah virus who would die from encephalitis. All right, so we can do that. We have essentially all the information we need. Or we do, but we need to know a few things. If we scroll back to what we need here, we need to know p hat, which we have enough information for. We're given a confidence level to find z sub alpha over 2, and then of course we can find p hat, and we're given a sample size. So what we want to recognize here is that our sample size is the 94 patients who were infected with the Nipah virus. And let's see here, X would be 30 because it is 30 of those patients that died from encephalitis. So P hat would be the 30 over 94. And we can evaluate that, we can round it. Let's see here, do a little bit of rounding. And that would give us 0.31, let's go 3191, and that should be pretty good. Okay. Of course, that continues on for a while as well. So we have n, we have x, we have p hat. We're given 90% confidence. So alpha is equal to, right, 90% is 1 minus alpha. So alpha is 10% or 0.1. And of course, then alpha over 2 would be 0.05. So we have all of these numbers that we need to be able to plug in and continue on with our one proportion z interval procedure. So we want to do that. So we are applying procedure 12.1, the one proportion z interval procedure. Excellent. Of course, we want to begin by verifying our assumptions. So the first assumption is that we have a simple random sample. And is that the case? Let's see here. It doesn't specify that. It doesn't appear. But we can assume yes. Simple random sample. We'll say yes, close enough. All right. The next assumption that we need to verify is that, go back here, the number of successes and the number of failures are both 5 or greater. So is x greater than or equal to 5 and n minus x greater than or equal to 5? Yes. The number of observations that have a desired characteristic, right? We don't desire to die, but that's the characteristic we're interested in at this time. X, 30 people died, which is greater than or equal to 5. And minus x would be the 94 minus 30. So that would be 64. And of course, that's greater than or equal to 5 as well. So I've said, yes, it's satisfied in here. We can see that. All right, so then we move on and we take a look at our first step. So step 1 in this case. Step 1 is for us to find z sub alpha over 2. So again, for actually here, let's see here, find z sub alpha over 2. So for 90% confidence, we already said this, but alpha is equal to 0.1. So alpha over 2 is 0.05. That tells us that z sub alpha over 2 is equal to z sub 0.05. And if we wanted to, we could look this up on on table 2 of our, I believe it's table 2 here. See if I can find that. Here it is. It is table 2, areas under the standard normal curve. So if we wanted to take a look at this, we could find it. But we actually have quite conveniently that we've seen this several times, so we should be familiar with it. All right, so that gives us that portion. All right, so I'm going to begin step 2 on this page. Step 2. Step 2 is for us to actually find the confidence interval. So we're going to find the confidence interval, and then we're going to interpret it within the context of the problem as our final step. So in order for us to find the confidence interval, again, we want to observe all of the information that we have. So z sub alpha over 2 is 1.645. We found n was equal to 94, x is equal to 30, p hat is equal to 0.3191. And this is all of the information that we need in order for us to go ahead and, let's see here, find the confidence interval, right? Find the error and then the confidence interval. So the error is equal to z sub alpha over 2 times the square root of p hat times 1 minus p hat divided by n. Again, that formula is given here, but more, if you want more specifically, if you want to just follow along the procedure itself, that's given right here. Z sub alpha over 2 times the square root of p hat times 1 minus p hat all over n. Okay, that's all inside the square root there. Same thing. Same thing. All right. So this is 1.645 because that's the value of z sub alpha over 2. And then we've got, you can use the approximations for the decimal approximations here, or you can go ahead and say that it's 30 divided by 94 for p hat, and then 1 minus 30 over 94 for 1 minus p hat. And then, of course, it's divided by 94. Now, if you were to plug in the decimal approximations, that's absolutely fine. For the most part, that won't be an issue. But if you do your rounding too early, then the end result that you get may have some errors that have been made worse by rounding too early. So I'd always encourage you to use the fraction form, unless it happens to be something really convenient like 1/4 or not 1/3, 1/2, 3/4, tenths, fifths, that sort of thing. That would be okay. But in this case, I believe it's a long decimal. Okay. All right, so from here, we can plug that into our calculator and find that to be 0.07909, or round it to 0.791. So then the confidence interval itself, again, is the approximation, the point estimate, p hat, minus the error, to p hat plus the error. So that's going to be 0.3191 minus 0.0791, up to 0.3191 plus 0.0791. So that gives us 0.2400 up to 0.3982. Is that perfect? Not necessarily, right? I did do some rounding. So if you used more decimal places, you would find that this might round up to a 1, but that would stay a 2. That's fine. In your calculations, when you're computing by hand, include more decimal places than is needed for the final rounding result, okay? So if you need 3 decimal places, make sure that all your computations have 4 or maybe even 5 decimal places if you're using the decimal approximations. All right, but that gives us our confidence interval, so we can move on to not step 6, we have step 3 here, which is our interpretation. So for the interpretation, it should look very similar to what we had presented back in chapter 8 when we were looking at confidence intervals there. All right. So we can be 90% confident that between 24%, 24.0%, and 39.8%, 39.8% of those infected with, right, now we want to be cautious here. They're not infected with encephalitis, they are infected with the Nipah virus. So infected with the Nipah virus. Let's see here, will die from encephalitis. Excellent. Encephalitis. There we go. There we go. Excellent. So this is actually pretty relevant here as we live in a time of the COVID-19 virus. There are a lot of people that say that COVID-19 is terrible, which I'm sure is absolutely true. You may know someone that had a terrible experience with it, possibly even died, which is very unfortunate. I'm sorry if that's the case for you. One of the things that we should be aware of as well is that in many, or some, we'll say some cases, it's not the virus itself that has caused the issues, but actually how the person or the patient was treated who had it. So it's kind of, as this example might seem a little bit trivial or made up. Hey, what do we really care about that? Well, yeah, this example that we just worked through is actually pretty related to things that are happening now, right? For example, a ventilator can cause a lot of lung damage, and people who have COVID-19 can be put on a ventilator, and then the use of that causes some future issues. Okay, so was it the virus, or was it how the virus is treated, right? Encephalitis isn't Nipah, I don't think. I'm not a health expert, so maybe I shouldn't talk too much about this. You certainly shouldn't put too much stock in what I'm saying about details of viruses and whatnot. But right, we should be aware of what's going on is all I'm trying to say. That's it. All right, anyway, that's all that I wanted for this video. We'll take a look at finding a sample size for a specified margin of error in our next video. So that's it for now. I'll see you guys back here in the workshop very shortly.